For what? For angular parameters, that is rotational motion. So imagine a particle going along a circle. Okay? So all the linear parameters which we have studied, namely linear displacement, linear velocity, linear acceleration, all these we studied already, and we already have equations of motion for constant acceleration, etc., etc. Same thing we'll have in rotational motion also. When a particle goes along a circle, we have angular displacement, angular velocity, angular acceleration, etc., etc. So don't you think that we should have same structure of formulas in rotational motion also as we have in translatory motion or linear motion? What do you think? The only difference is that in linear motion, linear displacement will be there, whereas in rotational motion, angular displacement will be there. Rest everything will be same. The dependency on time will be same, isn't it? So we expect same kind of formulas and equations as we have in linear motion. So that's why I told you it is easy for you to remember. So now suppose we have, see, a part will compare parallel, simultaneously will compare so that you understand. So here I am taking linear and here I am taking angular motion or rotational. Okay. All the parameters are linear parameters which will be using. Parameters means variables. Physical quantity which vary from situation to situation, they are known as parameters. And here we will be using angular parameters. Angular parameters. Okay. For example, when we say linear displacement S, we will have angular displacement theta. If we have linear velocity V, we have angular velocity omega. If we have linear acceleration A, we will have angular acceleration alpha. Okay? Just as we have small elementary displacement ds, we will have small elementary angular displacement d theta. So V is ds by dt, omega is d theta by dt. A is dv by dt, alpha is d omega by dt. All the things are same to same. So we have this. See, a particle, when you start counting the time, you have t equal to 0. At that point of time, let us say velocity is u. After a time t, let the velocity acquired be v, and the displacement undergone is s, and acceleration is a. Very, very important, the linear acceleration must be constant. Do you agree? Because we are about to apply equations of motion. V equal to u plus at, etc., etc. They are all valid only when acceleration is constant. If variable acceleration, you have to integrate. You know, differentiation, integrations, all those things are required for variability. Now, similarly here let us say that initially when you started counting the time, the angular velocity was omega naught. Meanwhile, it underwent an angular displacement theta, and now after time t, let us say after time t, the angular velocity became omega and the angular acceleration is alpha. Angular acceleration will be like this, and this is constant. Angular acceleration is constant. So we have same type of equations. So one equation we know it is v equal to u plus at. Similarly, here we have final angular velocity is initial angular velocity plus alpha t. Time will remain same. There is no linear time and angular time. Time remains time. Then we have v square equal to u square plus 2as. Similarly, here we have omega square is equal to omega naught square plus 2 alpha theta. Instead of linear displacement, we have to take angular displacement. Then we have the S is equal to ut plus half at square. Similarly, here we have angular displacement is equal to omega naught t plus half alpha t square. Also, you can write it as Vt minus half at square. So here we will write omega t minus half alpha t square. You can also write it as u plus v by 2, that is mean velocity into time. Here also same thing, mean of initial and final angular velocities by 2, this is into time. Okay? Then finally, from this, for the nth second, displacement during the nth second, you know it is u plus a by 2 into 2n minus 1. Similarly here, displacement during the nth second is omega naught plus alpha by 2 into 2n minus 1. So all these are, just look at the structure of the formulas. Structure of the formulas are identical. So since you are already aware of these equations, so it's not very difficult for you to remember them. Just you need to replace. Replace u with what? Omega naught. Replace a with what? Alpha. Replace s with what?
Theta.
SI unit of s is meter. SI unit of theta is radian. Is it okay? So I hope applications is similar because you have already studied these equations. You know how to apply. Same you have to apply in rotational motion. So concept remains same. Do you agree? Concept remains same. Whether it is lemon rice or tamarind rice. Instead of lemon, you have to use tamarind. What do you say? Nimkai full place lo chenfund full use that. Lemon rice, tamarind rice. Ata, you see, in Hindi we call pokhal bhat. Pokhal bhat, samajh rahe ho? You don't know. Who is from Hindi? Anyway, Telugu lo cheptanu. Sallanu, Ginjanu.
Sir.
Now, leave the Sallanu. Let us talk of Ginjanu. See, अरे माड़ भात हिंदी बोलते माड़ भात जान रहे हो ना see you understand what is genji or mad means when you cook rice then the extra water is taken out, extra rice. When you are cooking rice not in a cooker, in an ordinary pan, when you cook rice the extra water is drained, no? So that addition what is known as Genji, that is Mad. In Hindi we call Mad. Telugu we call it as Genji. In Kannada also it is known as Genji. So poor people who can't afford for pulse, pappu, dal, people who cannot afford for pappu, that is dal, they eat Genjannu. माड़ भात खाते बेचारा क्योंकि दाल खाने की हैसियत नहीं है उनको. जिनकी हैसियत नहीं है, दाल महंगा है, तो क्या माड़ से मिला के नमक मिर्च कुछ भी प्याज वाज पचमिरपकाय उल्लिपाय ఏదో నంచుకుంటారు. So poor people, labor class people, they can't afford dal. Now when I was in Mangalore, Karnataka, Mangalore, it's a coastal area. Once I visited a good restaurant there. I took the menu, I saw what specialty is there. I saw there Ganji Bhat. Ganji Bhat was there in a big restaurant. Ganjanu restaurant menu undi. Since it's a coastal area, just like our Visakhapatnam, Mangalore is a coastal area, so a lot of fishes are available. So they'll give Ganji Bhat and fish. Nanchukodan fish untadi. A big restaurant where high-fi people come, 3-star, 4-star, 5-star people come. In such kind of a restaurant, you have Ganji Bhat as one of the dishes. So, in other parts, northern India and all, poor people eat, poor people they consume Ganji Bhat. Such is it. Poor people